Welcome to Sleepy Science Hub. I'm so glad you've joined me tonight for this gentle journey into one of Earth's most mysterious and peaceful realms. As you settle in, let me know where in the world and at what time you're watching. Whether you're nestled comfortably in bed as the evening settles around you, or perhaps finding a quiet moment in the early hours of morning, you've discovered the perfect time to explore the serene depths of our planet's oceans together. Now, get comfortable. Adjust your pillows, let your shoulders sink into relaxation, and take a slow, deep breath. Feel the air fill your lungs completely, then release it gently, allowing any tension from your day to simply float away like bubbles rising to the surface. Tonight, we're going to descend slowly and peacefully into the deep ocean, discovering how life thrives under pressures that would seem impossible, yet create some of the most beautiful and adapted creatures on our planet. Take another gentle breath, and let's begin our descent. Imagine yourself standing at the edge of a calm, pristine ocean on a perfect morning. The sun hangs low on the horizon, painting the water's surface in soft shades of gold and pale blue that seem to glow from within. The gentle waves lap rhythmically against your feet, cool and refreshing, carrying with them the clean, salt-tinged scent of the open sea. There's no wind, no disturbance, just the peaceful, eternal rhythm of water meeting shore, a sound that has echoed across this planet for billions of years. As you wade slowly into the welcoming water, you feel its temperature embrace you like a comfortable blanket. The ocean here is crystal clear, so transparent that you can see your feet on the sandy bottom even as the water reaches your waist. Small fish dart playfully around your legs, their silver scales catching the sunlight in brief, dancing flashes. The water supports your weight effortlessly, and you feel the gentle buoyancy that makes every movement smooth and graceful. You begin to swim forward with slow, easy strokes, moving away from the shore toward the deeper blue that stretches endlessly toward the horizon. As you glide through the water, you notice how the sunlight penetrates the surface, creating dancing patterns of light and shadow that shift and shimmer with each gentle wave. The water around you is alive with tiny particles, microscopic plankton that drift like stars in a liquid sky, each one a small miracle of life adapted to this aquatic world. Gradually, almost imperceptibly, the water beneath you deepens. The sandy bottom that was once clearly visible begins to fade into a soft, hazy blue-green. You're not swimming down, but rather floating peacefully on the surface as the ocean floor slopes gently away beneath you. The feeling is wonderfully secure and calming, like resting on a vast, gentle waterbed that extends in all directions beyond the horizon. As you float here in perfect comfort, supported by the salt water's natural buoyancy, you begin to understand that you're experiencing something remarkable. The water that holds you so gently is not weightless. It has mass, substance, presence. Each drop of seawater contains dissolved minerals collected from rivers and streams, from ancient rocks worn away by centuries of rain, from volcanic vents deep beneath the ocean floor. This water has a story, a history, and a subtle but measurable weight. The pressure you feel as you float is gentle and even, distributed across every inch of your body. It's the pressure of our atmosphere, about 14.7 pounds pressing on every square inch of your skin. But you don't feel this pressure as uncomfortable or constraining because you've lived with it your entire life. Your body is perfectly adapted to it, your blood pressure balanced against it, your lungs designed to work within it. It's like wearing a perfectly fitted, invisible suit that supports and protects you. Now, imagine that you're wearing a special suit that allows you to breathe underwater, perfectly safe and comfortable, maintaining that same gentle pressure around your body. As you begin to descend slowly beneath the surface, the transformation is gradual and beautiful. The dancing patterns of sunlight on the water's surface become a shimmering ceiling above you, like looking up at the most beautiful stained glass window ever created, with patterns that shift and change in endless, mesmerizing variations. The The first few feet of descent feel almost the same as floating at the surface. The water around you is still bright and clear, filled with the same golden light that illuminated the surface moments before. You can see in all directions, and the ocean reveals itself as a three-dimensional space of incredible beauty and peace. Small fish continue to swim around you, their movements creating gentle currents that you can feel against your skin like the softest underwater breeze. As you sink deeper, perhaps 10 or 15 feet below the surface, you begin to notice subtle changes in your environment. The light becomes slightly softer, less harsh, filtered through the water above you into something gentle and diffused. The temperature drops just a degree or two, creating a refreshing coolness that feels wonderfully pleasant against your skin. Most remarkably, you can feel a very gentle increase in pressure, so subtle that it's more like a soft, reassuring embrace than anything uncomfortable. This increased pressure comes from the weight of the water above you. Water is much denser than air, about 800 times heavier. This means that every 33 feet of depth adds another full atmosphere of pressure to your body. But your special suit adjusts perfectly, maintaining your comfort while allowing you to experience this fundamental change in your environment. The pressure increases so gradually that it feels like sinking slowly into the world's most comfortable armchair, surrounded by the gentle support of the water. At 30 feet deep, you pause in your descent to observe the changes around you. The sunlight filtering down from above has taken on a deeper, richer quality. The reds in the spectrum are beginning to fade, absorbed by the water, leaving behind blues and greens that seem to glow with their own inner light. This isn't a loss, but a transformation. The ocean is painting the world in its own palette, creating an environment of incredible serenity and beauty. The fish around you at this depth are slightly different from those near the surface. Their bodies seem more streamlined, their movements more efficient. You're beginning to see the first subtle adaptations to pressure and depth. Some fish have swim bladders, internal gas-filled organs that help them maintain neutral buoyancy. As the pressure increases with depth, these swim bladders compress slightly, and the fish adjust by secreting or absorbing gases to maintain their balance in the water. A school of small silver fish swims past you in perfect synchronization, their bodies moving as one coordinated organism. Each fish maintains its position relative to its neighbors with precision that seems almost magical, but it's actually the result of pressure-sensitive organs along their sides called lateral lines. These organs can detect the slightest changes in water pressure and movement, allowing the fish to sense the presence and movements of their schoolmates even without seeing them. As you continue your gentle descent to 50 feet, then 75, the pressure around you continues to increase in its gentle, gradual way. At this depth, the pressure on your body is more than twice what it was at the surface, but the change has been so gradual and your suit so perfectly designed that you feel only a pleasant, enveloping sensation like being wrapped in the softest, most supportive blanket imaginable. The light continues its beautiful transformation as you descend. By the time you reach 100 feet, the world around you has become a cathedral of blue and green light. The harsh yellows and bright whites of surface sunlight have been filtered away, leaving behind colors that seem to emanate peace and tranquility. This blue light has a special quality. It seems to slow time itself, creating an environment where everything moves with deliberate grace and purpose. The creatures you encounter at this depth show more pronounced adaptations to their pressure-rich environment. A sea turtle glides past you with movements so graceful they seem choreographed, its body perfectly adapted to life in this underwater realm. The turtle's lungs can compress dramatically under pressure without damage, and its blood carries oxygen more efficiently than land animals, allowing it to hold its breath for hours while diving to incredible depths. You notice that your own breathing has slowed and deepened in response to this peaceful environment. The rhythm of your breath matches the gentle currents around you, creating a sense of harmony between your body and the ocean itself. This is one of the most wonderful aspects of the deep ocean environment. It naturally induces a state of calm and relaxation that seems to slow your entire metabolism. At 150 feet deep, you're now experiencing pressure that's nearly 5 times greater than at the surface, yet feels completely natural and comfortable. Your suit continues to maintain perfect equilibrium with your body's internal pressure, demonstrating the remarkable engineering that makes deep-sea exploration possible. Around you, the ocean has become a realm of twilight beauty, where bioluminescent creatures begin to appear like living stars in the gentle darkness. A jellyfish drifts past you, its translucent bell pulsing with slow, hypnotic contractions. The creature's body is perfectly adapted to pressure, composed mostly of water itself. It experiences no stress from the increased pressure because liquids, unlike gases, don't compress significantly. The jellyfish moves through the water column with effortless grace, rising and falling on currents, its internal pressure always perfectly matched to its external environment. You encounter a small octopus resting on a rocky outcrop, its soft body demonstrating another approach to dealing with pressure. Unlike vertebrates with rigid skeletons and gas-filled organs, the octopus's body can adjust to pressure changes with remarkable flexibility. Its tissues are largely incompressible, and its intelligence allows it to recognize and adapt to pressure changes in ways that seem almost miraculous. The rock formation where the octopus rests tells its own story of pressure adaptation. These rocks formed on ancient ocean floors under tremendous pressure, their crystals aligned and compressed into structures that can withstand forces that would crush surface materials. The geology of the ocean floor is shaped by pressure just as much as the biology, creating landscapes of incredible beauty and stability. As you reach 200 feet in depth, you pause to reflect on the journey so far. The pressure around you is now more than 6 times that at the surface, equivalent to having a weight of nearly 100 pounds pressing on every square foot of your body. Yet rather than feeling crushed or constrained, you feel supported and embraced by this pressure. It's like being held gently but firmly by the ocean itself, surrounded by a medium that supports every movement and cushions every action. The water around you at this depth has taken on an almost mystical quality. The deep blue light seems to come from everywhere and nowhere, creating an environment that exists nowhere else on Earth's surface. This is the beginning of the ocean's twilight zone, where sunlight becomes increasingly scarce and life must adapt to both pressure and the growing darkness. A school of lanternfish swims past, their bodies dotted with tiny bioluminescent organs called photophores. These living lights twinkle like stars in the ocean twilight, each fish a small constellation moving through the water. The pressure at this depth doesn't affect their light production. In fact, many deep-sea creatures produce their brightest lights in the highest pressure environments, using bioluminescence for communication, hunting, and defense. The temperature has continued to drop gradually as you've descended, now several degrees cooler than at the surface. This cooling isn't uncomfortable. Your suit maintains perfect thermal balance, but it's another reminder of how the ocean changes with depth. The combination of increasing pressure and decreasing temperature creates unique chemical and physical conditions that shape every aspect of life in the deep ocean. You notice that your movements through the water have become even more graceful and efficient. The increased density and pressure of the water at this depth provide more resistance, making every movement more deliberate and meaningful. It's like swimming through liquid crystal, where each stroke propels you smoothly and controllably through your three-dimensional environment. A large fish swims by in the distance, its body silver bright against the deep blue background. Even at this distance, you can see that it moves with a different quality than surface fish, more slowly, more deliberately, conserving energy in an environment where food is less abundant and every calorie counts. The fish's body shows subtle adaptations to pressure, slightly different proportions, more flexible bone structure, and specialized organs that function efficiently under these conditions. As you prepare to continue your descent into even deeper waters, you feel a profound sense of peace and wonder. The pressure that surrounds you, far from being threatening or uncomfortable, has become a supportive presence that seems to enhance every sensation and slow every moment to a pace that allows complete appreciation of the ocean's beauty. You're discovering that pressure, rather than being a barrier to life, is actually a fundamental organizing principle that shapes some of the most beautiful and perfectly adapted creatures on Earth. The gentle blue light that surrounds you continues to work its calming magic, slowing your breathing and heartbeat to a rhythm that matches the eternal patience of the deep ocean. Here, time moves differently. Pressure becomes support, and the weight of water above becomes not a burden, but a blessing that creates conditions for life forms of incredible beauty and adaptation. In this peaceful twilight realm, you begin to understand that pressure is not something life must struggle against, but something it can embrace and use. The organisms around you don't fight the pressure. They incorporate it into their very being, using it to enhance their abilities and create forms of beauty that exist nowhere else in the universe. As you float here in perfect comfort, surrounded by the gentle embrace of increasing pressure, you prepare to continue your journey into even deeper realms where pressure creates even more wonderful adaptations and peaceful forms of life. As you continue your gentle descent through the ocean's embrace, you begin to understand water in a completely new way. Each drop of the clear, blue liquid that surrounds you carries weight, substance, and presence that becomes more noticeable with every foot you descend. The water is not empty space through which you move, but a medium with its own character, its own personality shaped by the incredible forces that govern life in the deep ocean. At 250 feet below the surface, you pause to truly appreciate the transformation that has occurred around you. The pressure embracing your body is now nearly 8 times what you experienced at the surface, yet your specially designed suit maintains perfect equilibrium with your internal systems. You feel supported, cushioned, held by the ocean in a way that creates not constraint but comfort. It's as if you're resting in the most perfectly designed reclining chair, where every surface and curve supports your body in ideal alignment. The water around you has taken on a quality that seems almost solid in its presence. When you move your hand through it, you can feel its resistance not as an obstacle, but as a gentle guide that shapes your movements into something more graceful and deliberate. Each gesture becomes a collaboration between your intention and the water's natural flow, creating movements that are both purposeful and deeply relaxing to perform. Above you, the ceiling of dancing light from the surface has become a distant memory, visible now only as the faintest suggestion of brightness in the deep blue canopy overhead. The light that reaches you at this depth has traveled through hundreds of feet of water, each foot filtering and transforming the sunlight until what remains is something entirely new, a gentle, omnidirectional glow that seems to come from the water itself rather than from any external source. This transformation of light reveals one of the most fundamental aspects of how pressure shapes the deep ocean environment. Water doesn't just press on objects within it. It actively filters and modifies energy in all its forms. The red wavelengths of sunlight, with their longer waves and lower energy, are absorbed first, leaving behind the blues and greens that penetrate deeper. By the depth you've reached, even these blues are becoming subdued, creating an environment where bioluminescence, living light produced by the creatures themselves, begins to play an increasingly important role. A large fish glides past you in the distance. Its body is study in pressure adaptation that demonstrates the beautiful relationship between form and environment. The fish's swim bladder, that remarkable organ that helps control buoyancy, has adapted to the increasing pressure by developing specialized cells that can secrete gases directly into the bladder or absorb them as needed. This biological engineering allows the fish to maintain perfect neutral buoyancy at any depth, floating effortlessly through the water column without sinking or rising unless it chooses to do so. You observe the fish's movements and notice how they differ from the quick, darting motions you might see near the surface. Here, every movement is measured, efficient, purposeful. The increased density of the water at this pressure means that each motion requires more energy, but also means that each motion is more effective. The fish moves through the water like a dancer through honey, each gesture flowing smoothly into the next with a grace that speaks of millions of years of evolutionary refinement. The pressure at this depth affects not just the large, obvious features of ocean life, but the smallest details as well. The fish's scales have a different quality here, slightly more flexible to accommodate the subtle changes in body shape that occur under pressure. Its gills work with increased efficiency, extracting oxygen from water that is more densely packed with dissolved gases. Even the fish's lateral line system, those pressure-sensitive organs that detect movement and vibration, operates with enhanced sensitivity in this pressure-rich environment. As you continue your descent, you encounter a phenomenon that perfectly demonstrates the gentle power of water pressure. A small piece of marine snow, a delicate aggregate of organic particles that drifts down from the surface layers, floats past you. At the surface, this material would be light and airy, easily disturbed by the slightest current. Here, under pressure, it has become more compact, more coherent, yet still maintains its essential character. The pressure hasn't destroyed it, but has refined it, condensed it into a more concentrated form of the nutrients it carries. This marine snow represents one of the ocean's most important transport systems, carrying energy and nutrients from the productive surface waters down to the deep-sea communities that depend on this gentle rain of organic matter. The pressure that shapes its journey also shapes the creatures that depend on it. At 300 feet deep, you observe small crustaceans that have specialized feeding appendages designed to capture these pressure-modified particles with incredible efficiency. The crustaceans themselves demonstrate fascinating adaptations to the pressure environment. Their exoskeletons, which must be rigid enough to protect their soft internal organs, yet flexible enough to allow for growth and movement, have evolved to work optimally under these conditions. The pressure actually helps support their body structure from the outside, reducing the stress on their internal support systems and allowing them to maintain their shape with less energy expenditure. A jellyfish drifts past you, its translucent bell pulsing with the slow, hypnotic rhythm that characterizes life at these depths. The creature's body provides perhaps the most elegant solution to the challenge of pressure adaptation. By being composed primarily of water itself, it experiences no pressure differential between its internal and external environment. The jellyfish doesn't resist the pressure, it becomes one with it, maintaining perfect equilibrium by essentially being pressure neutral. The jellyfish's movements through the water demonstrate how pressure can enhance rather than hinder biological function. Each pulse of its bell is amplified by the water's density, creating more efficient propulsion with less energy expenditure. The creature moves through its pressure-rich environment with a grace that would be impossible in the thin air of the surface world. Its body perfectly adapted to use the water's weight and density as tools for elegant locomotion. At 350 feet, you encounter a small school of squid that illustrates another remarkable approach to pressure adaptation. These cephalopods possess a unique organ called a cuttlebone, or, in the case of deeper water species, a specialized chambered structure that allows them to control their buoyancy with incredible precision. The squid can adjust the gas content of these chambers to compensate for pressure changes, essentially creating their own internal submarine ballast system. The squid's ability to change color provides a beautiful demonstration of how pressure affects even the most subtle biological processes. Their chromatophores, specialized color-changing cells, operate by contracting and expanding tiny muscles that reveal or conceal different pigments. Under pressure, these cellular mechanisms work with enhanced precision, creating color displays of extraordinary subtlety and beauty. The increased pressure actually stabilizes the cellular structures, reducing random thermal motion and allowing for more precise control of the color-changing process. As you watch the squid communicate through their color changes, you begin to understand that pressure creates not just physical adaptation, but also enhances the complexity of biological communication. The density of the water at this depth carries chemical signals more effectively, allowing for more nuanced chemical communication between organisms. Sound also travels differently here, faster and with less attenuation, creating an acoustic environment where subtle vocalizations and sonic signals can convey complex information across greater distances. A large ray glides beneath you, its flat body undulating with movements that seem to make the water itself dance. The ray's body plan represents another masterful adaptation to pressure environments. Its flattened shape distributes pressure evenly across a large surface area, while its flexible cartilaginous skeleton allows it to adjust its body contours in response to pressure changes. The ray moves through the water like a living carpet, its movements creating gentle currents that you can feel as they pass over your body. The ray's method of breathing demonstrates yet another elegant pressure adaptation. Instead of the rigid gill covers found in bony fish, the ray uses flexible spiracles, openings that can adjust their size and function based on pressure conditions. This allows the ray to maintain efficient gas exchange even as pressure increases, ensuring that its tissues receive adequate oxygen for the enhanced metabolic processes that pressure environments often require. At 400 feet deep, you're now experiencing pressure that is more than 12 times greater than at the surface. The weight of water above you is immense, hundreds of tons pressing down through the water column. Yet you feel only the gentle, supportive embrace that has characterized your entire descent. This paradox helps you understand one of the most important principles of pressure adaptation. It's not the absolute magnitude of pressure that matters, but how gradually and evenly it's applied. The creatures around you at this depth show increasingly sophisticated pressure adaptations. A group of small deep-sea fish swim past, their bodies slightly more robust than their shallow water cousins, with specialized proteins that maintain their structure and function under pressure. These pressure-adapted proteins demonstrate how life can modify its most fundamental chemical processes to thrive in extreme environments. The fish's eyes have also adapted to the pressure environment in fascinating ways. The increased pressure actually helps maintain the shape and optical properties of their eyes more consistently than would be possible in a low-pressure environment. The dense, pressure-rich water provides stable support for the delicate optical structures, reducing distortion and allowing for clearer vision in the dim light conditions that characterize these depths. You notice that your own perception has changed during the descent. The constant, gentle pressure seems to have enhanced your awareness of subtle sensations and movements. Your breathing has become deeper and more regular, synchronized with the peaceful rhythm of life around you. The pressure environment appears to naturally induce a meditative state, slowing thought processes and enhancing the quality of attention and observation. A small octopus emerges from a crevice in a rocky formation, its soft body demonstrating the ultimate in pressure adaptation flexibility. Unlike creatures with rigid internal structures, the octopus can adjust its internal pressure to match its environment instantaneously. Its body tissues are largely incompressible, and its remarkable intelligence allows it to recognize and respond to pressure changes in ways that seem almost magical. The octopus's movement through the water column provides a beautiful demonstration of pressure-assisted locomotion. It can adjust its internal pressure to become perfectly neutrally buoyant, then use its jet propulsion system to move through the water with incredible efficiency. The pressure environment actually enhances the effectiveness of its propulsion system, as the denser water provides more reaction mass for each jet of water expelled from its siphon. As you continue observing this remarkable creature, you notice how it uses the pressure environment to its advantage in other ways. When the octopus changes color and texture to blend with its surroundings, the pressure helps maintain the precise muscle tensions needed for complex camouflage patterns. The stable pressure environment reduces random molecular motion, allowing for more precise control of the chromatophores and other specialized cells that create its amazing disguises. At 450 feet, you encounter a phenomenon that perfectly illustrates how pressure shapes the entire character of deep ocean ecosystems. A marine snowfall, that gentle rain of organic particles from above, moves past you with a different quality than you observed at shallower depths. The particles have been compressed and concentrated by their journey through increasing pressure, creating more nutrient-dense packages that can support more efficient food webs. The creatures that feed on this marine snow have evolved feeding strategies that take full advantage of the pressure environment. Filter-feeding organisms like small crustaceans and polychaete worms use the water's density to their advantage, creating feeding currents that are more effective and energy efficient than would be possible in low-pressure environments. The pressure helps concentrate both food particles and dissolve nutrients, creating feeding opportunities that are both abundant and accessible. You observe a small shark swimming with a characteristic grace that marks all successful deep-water predators. The shark's body shows subtle but important adaptations to the pressure environment. Its cartilaginous skeleton is more flexible than bone, allowing it to adjust to pressure changes without structural damage. Its liver, enlarged and filled with low-density oils, helps maintain buoyancy while providing energy storage for the long periods between meals that characterize deep ocean life. The shark's sensory systems have also adapted to take advantage of the pressure environment. Its lateral line system, which detects pressure waves and water movements, operates with enhanced sensitivity in the dense, pressure-rich water. The shark can detect the movements of prey at greater distances and with more precision than would be possible in shallow water, making it a supremely effective predator in its pressure-adapted environment. As you reach 500 feet in depth, you pause to appreciate the profound transformation that has occurred in your understanding of pressure. What began as an abstract concept, the weight of water pressing down from above, has revealed itself as a fundamental organizing principle that shapes every aspect of life in the ocean. Pressure is not a constraint but a collaborator, not a barrier, but a tool that life uses to create forms of beauty and efficiency that exist nowhere else. The water around you at this depth has a quality that seems almost magical. It's not just a medium through which you move, but an active participant in every biological process you observe. The pressure creates stability where there might otherwise be chaos, precision where there might be randomness, efficiency where there might be waste. It's as if the ocean has discovered how to use the fundamental force of gravity to enhance and refine all the processes of life. Looking around you in this deep blue realm, you see not creatures struggling against their environment, but organisms that have embraced their pressure-rich world so completely that they've become living expressions of its fundamental principles. Every adaptation, every behavior, every biological process you observe has been shaped by pressure into something more elegant, more efficient, more beautiful than its shallow water equivalent. The gentle, supportive pressure that surrounds your body continues to create that wonderful sense of being held and cradled by the ocean itself. As you prepare to continue your descent into even deeper waters, you carry with you a new understanding of how pressure can be not a burden, but a blessing, not a challenge, but a gift that creates the conditions for some of the most remarkable life forms on Earth. The weight of water above you has become not something to be endured, but something to be celebrated, a force that creates rather than destroys, that enables rather than constrains, that transforms the simple act of living into something approaching art. As you descend beyond 500 feet, you enter one of the ocean's most magical realms, the twilight zone, where the last traces of sunlight fade into an eternal dusk that has shaped life in ways both subtle and profound. Here, at depths between 500 and 3,000 feet, the pressure continues its gentle but persistent increase, now reaching 15 to 20 times the pressure you experienced at the surface. Yet rather than feeling overwhelmed, you feel increasingly supported by this dense, embracing medium that seems to enhance every sensation and slow every moment to a pace that allows perfect appreciation of the wonders around you. The water at this depth has taken on an almost mystical quality. The deep blue that characterized your earlier descent has deepened into something richer and more complex, a color that seems to contain its own light source, glowing with an inner radiance that comes not from above, but from the living creatures that have made this twilight realm their home. This is the beginning of the bioluminescent world, where pressure and darkness have combined to create one of nature's most beautiful phenomena. Your first glimpse of this living light comes as a small, twinkling spark in the distance. A lanternfish swimming slowly through the water, its body adorned with rows of photophores that pulse with a gentle blue-green light. As your eyes adjust to the perpetual twilight, you begin to see that these lights are everywhere, scattered through the water like stars in a three-dimensional galaxy. Each light represents a creature that has adapted not just to the crushing pressure of the deep, but to the eternal darkness that defines this realm. A school of lanternfish swims past you, their synchronized movements creating patterns of light that flow through the water like liquid constellations. Each fish carries its own unique pattern of bioluminescent organs, a personal signature written in living light that serves multiple functions in this pressure-rich environment. The lights help the fish recognize members of their own species, coordinate group movements, and communicate in ways that the crushing pressure of the depths makes more efficient than any other form of signaling. The pressure at this depth affects bioluminescence in fascinating ways. The increased pressure actually stabilizes the chemical reactions that produce biological light, making them more efficient and longer-lasting than they would be at the surface. The dense water also carries the light more effectively, allowing bioluminescent signals to travel farther and remain visible for longer periods. In this pressure-enhanced environment, light becomes not just a tool for communication, but a fundamental organizing principle that shapes social behavior and ecosystem structure. As you continue your descent to 600 feet, you encounter a creature that demonstrates one of the most elegant adaptations to life in the Twilight Zone. A small deep-sea jellyfish drifts past you, its transparent bell pulsing with slow, deliberate contractions that propel it through the dense water with remarkable efficiency. But what makes this creature truly special is how it uses both pressure and bioluminescence to its advantage. The jellyfish's body is perfectly adapted to the pressure environment. Its tissues are nearly incompressible, allowing it to move between different depths without the physiological stress that would affect creatures with gas-filled organs. As it moves, the changing pressure actually helps pump water through its bell, enhancing its locomotion efficiency. When threatened, the jellyfish produces a spectacular display of bioluminescent flashes that create a burglar alarm effect, potentially attracting larger predators to whatever is disturbing it. The pressure at 700 feet, now more than 20 times surface pressure, has created an environment where every adaptation serves multiple purposes. A siphonophore, one of the ocean's most remarkable colonial organisms, floats past you like a living string of pearls. Each pearl is actually a specialized individual organism called a zooid, and together they form a creature that can stretch for dozens of feet through the water. The siphonophore's adaptation to pressure is remarkable in its complexity. Different zooids within the colony have specialized functions, some for feeding, some for reproduction, some for defense, and some for locomotion. The pressure environment has allowed this division of labor to become incredibly refined, as the stable, dense medium provides consistent support for the delicate connections between individual zooids. The entire colony moves through the water with a coordinated grace that would be impossible in a less pressure-stable environment. As you observe the siphonophore's hunting behavior, you see how pressure enhances its feeding strategy. The colony extends nearly invisible tentacles through the water, equipped with stinging cells that can capture small prey. The pressure of the deep water helps these tentacles maintain their extended position with minimal energy expenditure, creating an efficient fishing net that takes advantage of the ocean's own physics to capture food. At 800 feet deep, you encounter one of the Twilight Zone's most fascinating predators, a small deep-sea squid that demonstrates how pressure can enhance rather than constrain the complexity of behavior. The squid's body shows the characteristic adaptations of pressure zone dwellers: enhanced flexibility, specialized proteins that maintain function under pressure, and bioluminescent organs that serve multiple functions in this eternal twilight. The squid's hunting strategy reveals how pressure influences predator-prey relationships in the deep ocean. It moves through the water with deliberate patience, using its chromatophores not just for camouflage but for active hunting. The pressure environment allows the squid to maintain precise control over its color changes, creating patterns that can confuse prey or coordinate with other members of its species. The dense water carries chemical signals more effectively, allowing the squid to track prey through scent trails that would dissipate too quickly in surface waters. When the squid does strike, the pressure environment enhances the effectiveness of its attack. Its tentacles can extend with explosive speed through the dense water, and the pressure helps maintain the tentacles' rigidity during the crucial moments of prey capture. The squid's beak and radula, its feeding apparatus, work more efficiently under pressure, as the increased external pressure helps maintain the structural integrity of these delicate feeding tools. As you descend to 900 feet, you begin to encounter larger fish that show more dramatic adaptations to the pressure environment. A deep-sea cod swims past, its body noticeably different from its shallow water relatives. The fish's swim bladder has evolved into a more sophisticated organ, capable of secreting and absorbing gases to maintain neutral buoyancy across a wide range of depths. This adaptation allows the fish to move vertically through the water column without the energy expenditure that would be required to constantly swim to maintain depth. The cod's muscle structure has also adapted to the pressure environment. Its muscle fibers are more densely packed and contain specialized proteins that maintain their contractile function under pressure. These adaptations actually make the fish's movements more efficient than those of its shallow water relatives, as each muscle contraction generates more force in the dense, pressure-rich medium. The fish's sensory systems show remarkable adaptations to life in the twilight zone. Its lateral line system has become incredibly sensitive, capable of detecting the minute pressure waves created by the movements of other organisms through the dense water. The fish can essentially see through pressure, using the enhanced sensitivity that the deep water environment provides to navigate and hunt in conditions where visual cues are limited. At 1,000 feet, you encounter a phenomenon that perfectly demonstrates how pressure shapes behavior in the twilight zone. A daily migration is beginning, the largest animal migration on Earth, though few people are aware of it. Countless small organisms that spent the day in the safety of the deep waters are beginning their nightly journey toward the surface to feed in the more productive waters above. This vertical migration is made possible by the creature's adaptations to pressure change. Many of the migrating animals have specialized gas-filled organs that can adjust to rapid pressure changes, allowing them to travel hundreds of feet vertically without physiological damage. Others, like many jellyfish and soft-bodied creatures, are essentially pressure neutral and can move between depths with no pressure-related stress at all. The migration creates a moving layer of bioluminescence that rises through the water column like a living aurora. As millions of creatures ascend together, their combined bioluminescent displays create patterns of light that flow upward through the ocean like visible rivers of life. The pressure gradient they travel through actually enhances their bioluminescence, as the changing pressure helps trigger the chemical reactions that produce their living light. A large deep-sea shrimp swims past you, participating in this great migration. The shrimp's body shows clear adaptations to the pressure changes it experiences during its daily vertical travels. Its exoskeleton is more flexible than that of shallow water relatives, allowing it to adjust to pressure changes without structural damage. Its gills have specialized structures that can regulate gas exchange efficiency based on pressure conditions, ensuring adequate oxygen supply at any depth. The shrimp's eyes demonstrate another fascinating pressure adaptation. They are larger and more sensitive than those of shallow water species, designed to detect the faintest traces of bioluminescent light in the eternal twilight. The pressure environment actually helps maintain the shape and optical properties of these enlarged eyes, providing stable support that allows them to function with remarkable sensitivity. As you descend to 1,200 feet, The pressure around you has increased to nearly 40 times that at the surface. Yet your specially designed suit continues to maintain perfect equilibrium, allowing you to experience this remarkable environment in complete comfort. The water around you has taken on an almost supernatural quality, so dense and supportive that you feel as though you're floating through liquid crystal, every movement cushioned and guided by the ocean's gentle embrace. A deep-sea anglerfish passes in the distance, its body a masterpiece of pressure adaptation and energy conservation. The fish's most famous feature, its bioluminescent lure, demonstrates how pressure enhances biological function in the deep ocean. The lure's light-producing bacteria work more efficiently under pressure, creating a brighter, more stable light source that can attract prey from greater distances in the dense medium of the deep ocean. The anglerfish's body plan reflects the energy conservation that pressure makes possible. Its bones are less calcified than those of shallow water fish, making them more flexible and less energy expensive to maintain under pressure. Its metabolism operates at a slower rate than surface fish, but the pressure environment makes this reduced metabolic rate more efficient, allowing the fish to extract maximum energy from every food item it captures. At 1,500 feet, you encounter one of the Twilight Zone's most remarkable inhabitants, a vampire squid, despite its ominous name, actually a gentle creature that feeds on marine snow and organic particles drifting down from above. The squid's body demonstrates perfect adaptation to the pressure environment, with tissues that are essentially incompressible and a nervous system that functions efficiently under the extreme conditions of the deep ocean. The vampire squid's defensive behavior showcases how pressure can be used as a tool for survival. When threatened, it can turn itself inside out, presenting a spiny, less appetizing exterior to potential predators. This remarkable transformation is made possible by the pressure environment, which provides stable support for the squid's flexible body during the shape-changing process. The dense water helps maintain the structural integrity of the squid's tissues during this dramatic defensive display. As you continue your descent through the Twilight Zone, approaching 2,000 feet, you begin to see larger predators that have adapted to hunt in this pressure-rich environment. A deep-sea shark glides past with the effortless grace that characterizes all successful deep-water predators. The shark's body shows subtle but important adaptations to the pressure environment. More flexible cartilage, specialized liver oils that help maintain buoyancy, and sensory systems that take advantage of the enhanced signal transmission properties of the dense, pressure-rich water. The shark's hunting strategy demonstrates how pressure shapes predator behavior in the deep ocean. It moves slowly and deliberately, conserving energy while using its enhanced sensory systems to detect prey at great distances. The pressure environment allows it to detect even the smallest movements or chemical signals, making it an incredibly efficient predator despite its apparently leisurely hunting style. At 2,500 feet, you're now experiencing pressure more than 75 times greater than at the surface. The weight of water above you is enormous, thousands of tons pressing down through the water column. Yet you feel only the gentle, supportive embrace that has characterized your entire journey. This depth marks the transition from the Twilight Zone to the even deeper realms below, where pressure becomes an even more dominant force in shaping life. A large jellyfish drifts past, its bell nearly transparent in the eternal twilight. The creature's movements demonstrate the perfect harmony that can exist between a living organism and its pressure environment. Each pulse of its bell is precisely calibrated to the density and pressure of the water around it, creating propulsion that is both energy efficient and graceful. The jellyfish doesn't fight against the pressure. It collaborates with it, using the ocean's own physics to move through its three-dimensional world with minimal energy expenditure. As you prepare to leave the Twilight Zone and descend into the even deeper realms below, you reflect on the remarkable adaptations you've witnessed. Every creature you've encountered has found ways to not just survive, but thrive under pressures that would be instantly lethal to surface-dwelling organisms. They've transformed what could be seen as a hostile environment into a supportive medium that enhances their abilities and creates opportunities for forms of life that exist nowhere else on Earth. The bioluminescent displays that have illuminated your journey through the Twilight Zone represent more than just beautiful light shows. They demonstrate how pressure can enhance biological function rather than constrain it. The stable, dense environment of the deep ocean allows for chemical reactions and biological processes that would be impossible in the chaotic, low-pressure environment of the surface world. The gentle, supportive pressure that surrounds you has become more than just a physical sensation. It's a reminder of how the ocean's fundamental forces can nurture and enhance life, rather than threatening it. As you prepare to continue your descent into the midnight waters below, you carry with you a deep appreciation for the Twilight Zone's remarkable inhabitants and their elegant solutions to the challenges and opportunities presented by life under pressure. In this realm of eternal dusk, where pressure and darkness have combined to create some of nature's most beautiful adaptations, you've discovered that the ocean's crushing depths are not crushing at all, but supportive, nurturing, and filled with life forms that demonstrate the incredible creativity and resilience of life itself. The Twilight Zone has revealed itself not as a place of struggle and survival, but as a realm of collaboration between living organisms and the fundamental forces that govern their environment. As you descend beyond 3,000 feet, you enter the midnight zone of the ocean, where sunlight has never penetrated and where the pressure has become a fundamental architect of life itself. Here, in the bathypelagic zone extending from 3,000 to 13,000 feet, you encounter pressure levels that reach beyond 100 times the surface atmosphere. Yet rather than feeling overwhelmed, you discover an environment of such profound tranquility and ethereal beauty that it seems designed for meditation and peaceful contemplation. The water around you at this depth has taken on an almost mystical presence. It feels substantial, supportive, like a medium that exists somewhere between liquid and something more solid, yet retains the flowing, embracing quality that has made your entire descent so comfortable. The pressure at 3,500 feet, now more than 100 times surface pressure, creates an environment so stable and consistent that it seems to slow time itself, allowing every moment to expand into perfect appreciation of the wonders that surround you. In this midnight realm, bioluminescence reigns supreme. The darkness is not empty, but filled with living stars, creatures that have transformed the challenge of eternal night into an opportunity to create some of the most beautiful light displays in the natural world. Your first encounter with a truly deep-water bioluminescent creature comes as an ethereal chain of lights drifting through the water like a string of blue diamonds, a siphonophore colony that stretches nearly 40 feet through the midnight waters. This remarkable creature demonstrates how pressure enables biological complexity that would be impossible in shallow waters. The siphonophore's individual zooids are connected by tissues so delicate they could not maintain their integrity without the supportive pressure of the deep ocean. Each zooid performs a specialized function, and together they create a superorganism that moves through the water with coordinated grace. The pressure environment allows this colonial creature to maintain its extended form while moving through the water, creating a living constellation that pulses with gentle bioluminescent rhythms. The siphonophore's hunting strategy showcases how pressure enhances predator efficiency in the midnight zone. It extends nearly invisible fishing lines equipped with bioluminescent lures, using the water's density to maintain these delicate structures in perfect position. When small prey organisms are attracted to the lights and become entangled, the pressure helps the siphonophore contract its fishing lines with remarkable speed and precision, bringing captured prey to feeding zooids along the colony's length. As you continue your descent to 4,000 feet, you encounter a creature that embodies the midnight zone's mastery of bioluminescent communication. A deep-sea jellyfish approaches, its transparent bell adorned with intricate patterns of photophores that pulse in complex sequences. The jellyfish's light display is not random, but follows sophisticated patterns that serve as a form of communication in this pressure-rich environment. The pressure at this depth actually enhances the jellyfish's bioluminescent capabilities. The increased pressure stabilizes the biochemical reactions that produce light, making them more efficient and longer-lasting. The dense water carries the light signals farther and with less distortion than would be possible in shallow water. The jellyfish uses these pressure-enhanced signals to communicate with others of its species across vast distances in the midnight waters, coordinating behaviors and reproductive activities in ways that demonstrate remarkable sophistication. The jellyfish's movement through the pressure-rich water reveals another adaptation unique to the midnight zone. Its bell contracts with slow, powerful pulses that take full advantage of the water's density to create maximum propulsion with minimal energy expenditure. Between pulses, the jellyfish can glide for extended distances through the supportive medium, conserving energy in an environment where every calorie is precious. At 5,000 feet, where the pressure has reached nearly 150 times that at the surface, you encounter one of the midnight zone's most remarkable predators, a deep-sea anglerfish that demonstrates how pressure enables hunting strategies impossible in any other environment. The fish hangs motionless in the water, its grotesque but perfectly adapted form suspended by the dense, supportive medium around it. Its famous bioluminescent lure extends from its head like a living fishing rod, glowing with bacteria that thrive under the extreme pressure conditions. The anglerfish's hunting strategy exemplifies energy conservation in the pressure-rich environment of the midnight zone. Rather than actively pursuing prey, it uses the water's supportive properties to maintain position while its lure attracts curious prey organisms. The pressure environment allows the fish to remain perfectly still for hours or even days, waiting for the right moment to strike. When prey comes within range, the anglerfish can open its massive mouth and create a suction so powerful in the dense water that prey is drawn in faster than the eye can follow. The anglerfish's reproductive strategy reveals another way that pressure shapes life in the midnight zone. In many species, the much smaller male permanently fuses with the female's body, becoming essentially a living sperm-producing organ. This bizarre adaptation makes perfect sense in the pressure environment of the deep ocean, where finding a mate in the vast, sparsely populated waters would otherwise be nearly impossible. The pressure environment supports this unusual biological arrangement, allowing the fused pair to function as a single, highly efficient reproductive unit. As you descend to 6,000 feet, you encounter a phenomenon that perfectly demonstrates how pressure creates opportunities for biological innovation. A giant tube worm colony appears in the distance, growing around a hydrothermal vent where superheated water rich in chemicals rises from the ocean floor. These remarkable creatures have no digestive system in the conventional sense, instead hosting symbiotic bacteria and specialized organs that convert chemicals into energy. The tube worm's adaptation to extreme pressure is remarkable in its elegance. Their bodies are essentially pressure neutral, composed largely of incompressible tissues that can withstand the enormous pressures of the deep ocean without stress. The worms extend feathery feeding appendages into the water, filtering chemicals and bacteria from the pressure-rich environment. The high pressure actually helps concentrate the chemical nutrients the worms need, making their chemosynthetic lifestyle more efficient than it could be in shallow water. The tube worm colony demonstrates how pressure enables complex ecosystem development in the midnight zone. The dense, stable environment allows for the construction of permanent structures that would be impossible in the turbulent surface waters. Individual worms can grow to enormous sizes, some reaching over 8 feet in length, supported by the pressure environment that provides structural stability for their elongated bodies. At 7,000 feet, you encounter a creature that showcases the ultimate in pressure adaptation, a deep-sea octopus that moves through the midnight waters with fluid grace. Unlike its shallow water relatives, this octopus shows remarkable modifications for life under extreme pressure. Its body is softer and more gelatinous, allowing it to compress and expand in response to pressure changes without damage. Its 8 arms move through the dense water with enhanced sensitivity, using the pressure environment to detect the slightest movements of potential prey or predators. The octopus demonstrates intelligence adapted to the pressure environment of the midnight zone. It can solve complex problems related to navigation and hunting in the three-dimensional space of the deep ocean, using the pressure gradients and water density differences to orient itself and move efficiently through its environment. The creature's chromatophores work with enhanced precision under pressure, creating camouflage patterns that are more sophisticated and longer-lasting than those of shallow-water octopi. When the octopus moves, it does so with a grace that takes full advantage of the pressure environment. It can adjust its internal pressure to achieve perfect neutral buoyancy, then use its jet propulsion system to move through the water with remarkable efficiency. The dense, pressure-rich water provides excellent reaction mass for its propulsion system, allowing the octopus to change direction quickly and precisely while conserving energy. As you continue your descent through the midnight zone, reaching 8,000 feet where pressure exceeds 240 times that at the surface, you encounter schools of deep-sea fish that demonstrate collective behavior adapted to the pressure environment. These fish move in coordinated groups that take advantage of the water's density to create energy-efficient swimming formations. The pressure environment allows them to maintain precise spacing and coordination, swimming in formations that reduce drag and energy expenditure for all members of the school. The fish show remarkable adaptations to the pressure environment in their body structure and physiology. Their swim bladders have evolved into sophisticated pressure compensation organs that can function across a wide range of depths. Their muscle tissues contain specialized proteins that maintain contractile function under extreme pressure, actually becoming more efficient than shallow water muscle at these depths. The fish's sensory systems demonstrate how pressure enhances biological function in the midnight zone. Their lateral line organs can detect incredibly subtle pressure waves and water movements in the dense medium, allowing them to navigate and coordinate group movements with precision that would be impossible in shallow water. The fish essentially see through pressure, using the enhanced sensitivity that the deep water environment provides to maintain their complex social behaviors. At 9,000 feet, you encounter one of the midnight zone's most beautiful inhabitants, a deep-sea comb jelly that moves through the water like a living prism. The creature's body is nearly transparent, but its 8 rows of cilia catch and refract what little light exists at this depth, creating rainbow displays that seem to glow from within. The comb jelly's movement through the pressure-rich water demonstrates perfect adaptation to the midnight zone environment. The comb jelly's body plan takes full advantage of the pressure environment. Its gelatinous tissues are essentially incompressible, allowing it to move between different depths without physiological stress. The creature's cilia work more efficiently under pressure, creating propulsion that is both graceful and energy efficient. The dense water provides excellent support for the cilia's beating motion, allowing the comb jelly to maintain precise control over its movement and orientation. The comb jelly's feeding strategy demonstrates how pressure shapes predator-prey relationships in the midnight zone. It creates feeding currents that concentrate small prey organisms, using the water's density to help funnel food towards mouth. The pressure environment makes these feeding currents more stable and effective than they would be in shallow water, allowing the comb jelly to capture prey with remarkable efficiency. As you descend toward 10,000 feet, you encounter larger predators that represent the apex of pressure adaptation in the midnight zone. A deep-sea shark glides past with movements so fluid they seem choreographed, its body perfectly adapted to life under extreme pressure. The shark's cartilaginous skeleton is more flexible than bone, allowing it to adjust to pressure changes without structural damage while maintaining the strength needed for its predatory lifestyle. The shark's hunting strategy demonstrates how pressure enhances predator efficiency in the midnight zone. It moves slowly through the water, using its enhanced sensory systems to detect prey at great distances in the dense, pressure-rich medium. The shark's electroreception organs work with increased sensitivity under pressure, allowing it to detect the bioelectric fields generated by other organisms from remarkable distances. When the shark does strike, the pressure environment enhances the effectiveness of its attack. The dense water provides excellent support for high-speed swimming, allowing the shark to accelerate quickly while maintaining precise control. The pressure also helps the shark's jaws generate tremendous force, making it an incredibly effective predator in its pressure-adapted environment. At 11,000 feet, where pressure has reached nearly 330 times out of the surface, you encounter a phenomenon that demonstrates the midnight zone's role as a bridge between the water column and the deep ocean floor. Marine snow falls through the water like a gentle blizzard, carrying nutrients and energy from the productive surface waters down to the communities that depend on this organic rain. The pressure has transformed this marine snow, concentrating and preserving it during its long journey through the water column. The creatures that feed on marine snow at this depth show remarkable adaptations to maximize the efficiency of their feeding. Filter-feeding organisms use the water's density to create powerful feeding currents that concentrate food particles. The pressure environment allows them to extract maximum nutrition from each particle of marine snow, supporting complex food webs in an environment where energy is scarce and precious. As you approach 12,000 feet, nearing the bottom of the midnight zone, you encounter creatures that represent the ultimate expression of pressure adaptation. A deep-sea cucumber moves slowly across a patch of sediment that has settled on a rocky outcrop, its body demonstrating perfect adaptation to the extreme pressure environment. The creature's tissues are so well adapted to pressure that it literally cannot survive at shallow depths. It is as much a creature of the deep pressure environment as fish are creatures of water. The sea cucumber's feeding strategy takes full advantage of the pressure environment. It processes sediment and organic matter with incredible efficiency, extracting nutrients that would be unavailable to creatures not adapted to the chemical and physical conditions created by extreme pressure. The creature's digestive system works more efficiently under pressure, breaking down organic matter more completely and extracting maximum energy from its food sources. As you prepare to continue your descent beyond the midnight zone into even deeper realms, you reflect on the remarkable community of life you've encountered in these pressure-rich waters. Every creature you've observed has not merely adapted to the extreme pressure conditions. They've embraced pressure as a fundamental aspect of their biology, using it to enhance their abilities and create forms of life that exist nowhere else on Earth. The Midnight Zone has revealed itself as not a place of limitation, but of liberation, where the constraints of shallow water life are replaced by new opportunities created by pressure itself. The dense, supportive medium of the deep ocean allows for biological innovations that would be impossible in any other environment, creating a realm where life has discovered new ways to be beautiful, efficient, and successful. The gentle, omnipresent pressure that surrounds you continues to create that wonderful sense of being supported and embraced by the ocean itself. As you prepare to descend into the abyssal depths below, you carry with you a profound appreciation for the Midnight Zone's inhabitants and their elegant demonstrations of how life can not just survive, but flourish under conditions that transform pressure from a challenge into a creative force that enables new forms of biological artistry. As you descend beyond 13,000 feet, you enter the abyssopelagic zone, the abyss, where pressure reaches levels that transform the very nature of existence itself. Here, in depths that extend from 13,000 to 20,000 feet, you encounter pressure that exceeds 400 times that of the surface. Yet rather than experiencing any sense of constriction or discomfort, you discover an environment of such profound stillness and support that it feels like floating through liquid space. Cradled by forces so gentle and consistent, they seem designed for perfect peace and contemplation. The water at these depths has taken on an almost supernatural quality, so dense and substantial that it feels more like a supportive medium than ordinary seawater. At 14,000 feet, where pressure approaches 425 times surface levels, the ocean has become something that exists nowhere else on Earth. A realm where the normal rules of physics create entirely new possibilities for life. The pressure here is so immense that it would instantly compress any gas-filled object from the surface world. Yet for the creatures that call this realm home, it provides the perfect environment for forms of life so elegant and efficient they seem like living poetry. Your first encounter with a true abyssal creature comes as an ethereal vision drifting through the midnight waters. A deep-sea jellyfish unlike anything you've seen in shallower waters. This creature's body demonstrates perfect adaptation to the crushing depths. Its tissues so specialized for extreme pressure that they actually require these conditions to maintain their structure and function. The jellyfish moves through the dense water with movements so slow and deliberate, they seem to unfold in slow motion. Each pulse of its bell, taking full advantage of the medium's incredible density to create propulsion that carries it gracefully through its three-dimensional world. The jellyfish's bioluminescence at this depth reveals how pressure enhances biological processes in ways that seem almost magical. Its photophores produce light that is more intense and longer-lasting than anything possible in shallow water. The biochemical reaction stabilized and enhanced by the extreme pressure environment. The creature's light display serves multiple functions: communication with others of its species across the vast distances of the abyss, attraction of prey organisms, and defense against the few predators that exist at these extreme depths. As you continue your descent to 15,000 feet, you encounter a creature that embodies the abyss's mastery of energy conservation. A deep-sea anglerfish that has evolved into something that barely resembles its shallow water ancestors. This fish demonstrates how extreme pressure enables biological innovations that would be impossible anywhere else on Earth. Its body is soft and gelatinous, perfectly adapted to the pressure environment that would instantly crush a surface fish, yet provides this creature with optimal support for its deep-water lifestyle. The anglerfish's hunting strategy showcases the ultimate in pressure-adapted efficiency. It hangs motionless in the water, supported by the dense medium around it, its bioluminescent lure glowing like a tiny star in the absolute darkness of the abyss. The extreme pressure environment allows the fish to maintain this position for weeks or even months without movement, conserving energy in an environment where food is scarce and every calorie must be carefully managed. When prey finally approaches, attracted by the hypnotic glow of the lure, the anglerfish can strike with lightning speed, the pressure environment actually enhancing the effectiveness of its suction feeding. The fish's reproductive adaptation to the abyssal environment demonstrates one of nature's most remarkable solutions to the challenge of finding mates in the vast, sparsely populated depths. The male anglerfish, much smaller than the female, permanently fuses with her body when they encounter each other in the darkness. This fusion is made possible by the pressure environment, which supports the complex physiological changes needed for two separate organisms to become one. The pressure actually helps maintain the integrity of the fused tissues, creating a single organism that can reproduce successfully in the extreme conditions of the abyss. At 16,000 feet, where pressure has reached nearly 500 times surface levels, you encounter one of the abyss's most remarkable ecosystems, a whale fall, where the carcass of a great whale has sunk to the ocean floor and created an oasis of life in the desert of the deep ocean. This massive source of organic matter supports a complex community of creatures that demonstrate the most extreme adaptations to pressure and the specialized conditions of the abyss. The whale fall ecosystem reveals how pressure enables long-term biological processes that would be impossible in shallow water. The extreme pressure helps preserve the whale carcass for decades, creating a sustained source of nutrients that can support multiple generations of deep-sea organisms. Hagfish burrow into the carcass, their eel-like bodies perfectly adapted to the pressure environment. Their lack of a rigid skeleton allows them to compress and expand with pressure changes, while their primitive circulatory system functions efficiently under the extreme conditions of the abyss. Around the whale fall, specialized bacteria thrive in the pressure-rich environment, breaking down the whale's tissues and converting the organic matter into forms that other organisms can use. These bacteria are among the most pressure-adapted life forms on Earth. Their cellular mechanisms so specialized for extreme conditions that they cannot survive at surface pressures. The bacteria create a foundation for the whale fall food web, supporting creatures that exist nowhere else on the planet. Tube worms colonize parts of the whale carcass, their bodies demonstrating remarkable adaptations to both extreme pressure and the chemically rich environment created by decomposition. These worms have no digestive system, instead hosting symbiotic bacteria that convert chemicals into energy. The pressure environment enhances this chemosynthetic process, allowing the bacteria to work more efficiently and support larger populations of tube worms than would be possible in shallow water. As you descend to 17,000 feet, you encounter mobile predators that represent the apex of abyssal adaptation. A deep-sea skate glides over the seafloor with movements that seem to defy the enormous pressure that surrounds it. The skate's cartilaginous skeleton is perfectly adapted to the pressure environment, flexible enough to adjust to pressure changes yet strong enough to support the animal's predatory lifestyle. Its flattened body takes advantage of the dense water to create efficient locomotion, each undulating movement propelling it smoothly through the pressure-rich medium. The skate's hunting strategy demonstrates how pressure enhances predator efficiency in the abyss. It uses electroreception organs that work with incredible sensitivity in the dense, conductive medium of the deep ocean. The pressure environment actually enhances the transmission of electrical signals, allowing the skate to detect the bioelectric fields of buried prey organisms from remarkable distances. When it strikes, the dense water provides excellent support for the rapid movements needed to capture prey before it can escape. The skate's reproduction reveals another way that pressure shapes life in the abyss. Its eggs are enclosed in tough, leathery cases that can withstand the extreme pressure environment during the long incubation period required in the cold, high-pressure conditions of the deep ocean. The pressure actually helps maintain the integrity of these egg cases, protecting the developing embryos for the months or years needed for them to reach maturity in the challenging environment of the abyss. At 18,000 feet, you encounter creatures that push the boundaries of what seems possible for complex life under extreme pressure. A deep-sea octopus moves across the seafloor with fluid grace, its soft body demonstrating the ultimate in pressure adaptation. Unlike its shallow water relatives, this octopus shows remarkable modifications for life under crushing pressure. Its tissues are more gelatinous, its nervous system operates more slowly but with enhanced precision, and its 8 arms move through the dense water with sensitivity that seems almost supernatural. The octopus's intelligence manifests differently in the pressure environment of the abyss. It solves problems related to navigation and hunting in ways that take advantage of the unique properties of the deep ocean environment. The creature can detect minute changes in pressure and water density, using these subtle cues to navigate across the vast expanses of the abyssal seafloor. Its memory appears to be enhanced by the stable conditions of the deep ocean, allowing it to remember the locations of food sources and safe hiding places across enormous distances. The octopus's camouflage abilities reach their ultimate expression in the pressure environment of the abyss. Its chromatophores work with precision that is impossible in shallow water, the pressure environment providing stable support for the complex muscle contractions needed to create intricate color and texture patterns. The creature can transform itself to match not just the visual appearance of its surroundings, but also their tactile properties, creating camouflage so perfect it seems like magic. As you approach 19,000 feet, nearing the bottom of the abyssopelagic zone, you encounter one of the most remarkable demonstrations of pressure adaptation in the animal kingdom. A deep-sea fish swims past that shows such extreme modifications for life under pressure that it barely resembles its ancestral form. The fish's body is soft and almost transparent, its skeleton reduced to the minimum needed for basic function. Its swim bladder has been replaced by specialized lipid-filled organs that maintain buoyancy without the gas-filled chambers that would be crushed at these depths. The fish's sensory systems represent the pinnacle of pressure-enhanced biology. Its lateral line organs can detect water movements so subtle they would be undetectable in shallow water, allowing it to navigate and hunt in the absolute darkness of the abyss with remarkable precision. Its eyes, while small, are incredibly sensitive, capable of detecting the faintest bioluminescent signals from other organisms in a pressure-rich environment where light travels farther and with less distortion than in shallow water. The fish's metabolism operates at a pace that seems impossibly slow by surface standards, yet is perfectly adapted to the energy-limited environment of the abyss. The pressure environment allows for biochemical processes that are more efficient than their shallow water counterparts, enabling the fish to extract maximum energy from the scarce food resources available at these extreme depths. Every movement, every biological process is optimized for energy conservation in ways that demonstrate the remarkable creativity of evolution under pressure. At 20,000 feet, at the very bottom of the abyssopelagic zone, you encounter the deep ocean floor itself, a landscape shaped entirely by pressure and the unique conditions it creates. The sediment here is different from anything found in shallow water, compressed and modified by the enormous pressure into a substrate that provides stable habitat for specialized bottom-dwelling creatures. The pressure has created chemical and physical conditions that support forms of life so specialized they exist nowhere else on Earth. Sea cucumbers move slowly across this pressure-modified landscape, their bodies so perfectly adapted to the extreme conditions that they literally cannot survive at lower pressures. These creatures demonstrate the ultimate expression of pressure adaptation. They have become so specialized for life under crushing depths that they are as much creatures of pressure as they are creatures of the ocean. Their feeding strategy takes advantage of the unique chemical conditions created by extreme pressure, extracting nutrients from sediments in ways that would be impossible in shallow water. The sea cucumber's role in the abyssal ecosystem demonstrates how pressure creates opportunities for biological innovation. They process vast quantities of sediment, breaking down organic matter and recycling nutrients in ways that are enhanced by the pressure environment. Their digestive systems work more efficiently under pressure, allowing them to extract energy from sources that would be unavailable to shallow water organisms. As you pause at the bottom of the abyssopelagic zone, reflecting on the remarkable journey through the crushing depths, you understand that you have witnessed not just adaptation to extreme conditions, but the transformation of those conditions into opportunities for forms of life that represent some of evolution's most creative solutions. The pressure that could be seen as limiting has instead become liberating, enabling biological innovations and forms of beauty that exist nowhere else in the universe. The creatures of the abyss have shown you that pressure, far from being a constraint, can be a creative force that enables new forms of efficiency, beauty, and complexity. Every organism you've encountered has not just survived the crushing depths. They have embraced pressure as a fundamental aspect of their existence, using it to enhance their abilities and create forms of life that are perfectly suited to their pressure-rich environment. The gentle, omnipresent pressure that surrounds you at these depths continues to create that wonderful sense of being supported and embraced by the ocean itself. As you prepare to continue your descent into even deeper realms, you carry with you a profound appreciation for the abyss and its inhabitants, who have demonstrated that even under the most extreme conditions, life finds ways not just to survive, but to create beauty, efficiency, and complexity that inspire wonder and awe. As you descend beyond 20,000 feet, you enter the deepest realm of Earth's oceans, the hydrothermal zone, named after Hades, the ancient underworld, yet revealing itself to be not a place of torment, but a realm of transcendent beauty and impossible life. Here, in the ocean's deepest trenches that plunge to depths exceeding 36,000 feet, you encounter pressure levels that reach beyond 1,100 times surface atmosphere. Yet your journey continues in perfect comfort, supported by technology that allows you to experience these crushing depths as the most peaceful and supportive environment imaginable. The water at 22,000 feet has transformed into something that seems to exist beyond the normal categories of matter. It feels almost solid in its density and support, yet retains the flowing, embracing quality that has characterized your entire descent. The pressure here, approaching 670 times that at the surface, creates an environment so stable and consistent that it seems to exist outside of time itself. Every movement through this ultra-dense medium feels deliberate and meaningful, as if the ocean has slowed to allow perfect appreciation of the wonders that exist only in these deepest places. Your first glimpse of life in the Hadal Zone comes as an ethereal vision that seems to challenge everything you thought you knew about the limits of life itself. A deep-sea amphipod, a tiny crustacean no bigger than your thumb, swims past with movements that demonstrate perfect adaptation to pressure levels that would instantly destroy any surface-dwelling organism. This tiny creature represents one of life's most remarkable achievements. The ability to not just survive, but thrive under pressure so extreme it approaches the theoretical limits of what complex life can endure. The amphipod's body reveals adaptations so sophisticated they seem almost alien in their perfection. Its exoskeleton is composed of specialized proteins that actually become stronger under extreme pressure, using the crushing force of the deep ocean as a structural advantage rather than a challenge to overcome. The creature's internal organs are protected by pressure-equalizing fluids that prevent crushing while maintaining the delicate chemical gradients needed for life. Most remarkably, the amphipod's nervous system operates more efficiently under extreme pressure, its neural signals enhanced by the ultra-dense medium that surrounds every cell in its body. As you descend to 25,000 feet, you encounter one of the Hadal Zone's most remarkable ecosystems. The walls of an oceanic trench, where specialized communities of organisms demonstrate life's incredible ability to colonize even the most extreme environments on Earth. The trench walls are not barren rock faces, but living communities where pressure-adapted organisms create ecosystems of stunning complexity and beauty. Bacterial mats cover portions of the trench walls, their microscopic inhabitants representing some of the most pressure-adapted life forms on the planet. These bacteria have evolved cellular mechanisms that not only tolerate extreme pressure, but actually require it for optimal function. Their cell walls are reinforced with specialized compounds that use pressure as a stabilizing force, while their metabolic processes operate at peak efficiency only under the crushing conditions of the Hadal Zone. The bacterial communities support populations of grazing organisms that demonstrate remarkable adaptations to trench life. Tiny worms move across the bacterial mats, their soft bodies perfectly designed to withstand pressure that would crush conventional organisms. These worms lack many of the gas-filled organs found in their shallow water relatives, instead relying on pressure-resistant tissues and specialized circulatory systems that function optimally under extreme conditions. At 28,000 feet, you encounter one of the deepest living fish ever discovered, a species of snailfish that represents the absolute pinnacle of vertebrate adaptation to extreme pressure. This translucent, ghostly creature swims through the ultra-dense water with movements that seem to unfold in slow motion, each gesture perfectly calibrated to the unique physics of the Hadal environment. The fish's body is so specialized for extreme pressure that it bears little resemblance to conventional fish anatomy. The snailfish's skeleton has been almost entirely replaced by cartilage and specialized connective tissues that remain flexible under crushing pressure. Its swim bladder, the gas-filled organ that helps most fish control their buoyancy, is completely absent, replaced by specialized lipid deposits that provide neutral buoyancy without any compressible components. The fish's muscle tissues contain unique proteins that actually improve their contractile function under extreme pressure, making the creature more agile and efficient in its crushing environment than its shallow water relatives could ever be in theirs. The snailfish's sensory systems reveal how extreme pressure can enhance rather than impair biological function. Its lateral line organs operate with extraordinary sensitivity in the ultra-dense medium of the hadal zone, allowing it to detect movements and pressure waves from remarkable distances. The fish can essentially see through pressure, using minute changes in water density and pressure to navigate and hunt in the absolute darkness of the deepest ocean. As you continue your descent toward 30,000 feet, you encounter formations that demonstrate how geological processes and extreme pressure combine to create unique habitats in the hadal zone. Underwater landslides have created fields of rocky debris where specialized communities of organisms have evolved to take advantage of the hard substrate in an environment otherwise dominated by soft sediments. Anemones, unlike any found in shallow water, attach themselves to these rocks, their bodies demonstrating remarkable adaptations to extreme pressure. These creatures have no gas-filled spaces that could be crushed, instead relying on pressure-resistant tissues and specialized internal fluids that maintain their structure under conditions that would destroy conventional marine life. The anemone's feeding tentacles work more efficiently under extreme pressure, using the dense medium to create powerful water currents that concentrate food particles and small prey organisms. The anemones support a community of small crustaceans and worms that have co-evolved to live in the unique microenvironment created by these pressure-adapted cnidarians. These tiny creatures demonstrate some of the most extreme specializations for hadal life. Their bodies so modified for crushing pressure that they literally cannot survive at lower depths. They are as much creatures of extreme pressure as they are creatures of the ocean. At 32,000 feet, you enter the deepest parts of the ocean trenches, where pressure approaches 970 times that at the surface, and the very concept of crushing depths reveals itself as a fundamental misunderstanding. Here, pressure is not crushing but creative, not destructive but enabling, creating conditions that allow for forms of life so specialized and beautiful they seem to belong to another world entirely. A deep-sea holothurian, a sea cucumber specifically adapted to the deepest ocean trenches, moves slowly across the seafloor with grace that seems impossible under such extreme conditions. This creature represents the ultimate expression of pressure adaptation. Its body so perfectly designed for the hadal environment that it has become one with the extreme conditions that define its world. The holothurian's tissues are essentially incompressible, composed of specialized proteins and cellular structures that not only resist pressure, but use it to enhance their biological functions. The creature's feeding strategy demonstrates how extreme pressure can create unique ecological opportunities. It processes sediments that have been compressed and chemically modified by their journey through the crushing depths, extracting nutrients that exist nowhere else on Earth. The holothurian's digestive system operates more efficiently under extreme pressure, breaking down organic compounds and extracting energy with an efficiency that would be impossible at lower pressures. The sea cucumber's role in the hadal ecosystem reveals how pressure creates entirely new forms of nutrient cycling and energy flow. It processes vast quantities of pressure-modified sediment, concentrating and redistributing nutrients in ways that support the unique food webs of the deepest ocean. The creature's waste products are themselves modified by the extreme pressure environment, creating chemical compounds that serve as the foundation for specialized bacterial communities found nowhere else on the planet. As you approach 35,000 feet, nearing the deepest points in Earth's oceans, you encounter sediments that have been transformed by pressure into something that barely resembles conventional ocean floor material. These pressure-modified sediments create a unique substrate that supports specialized communities of microorganisms whose existence challenges our understanding of the limits of life itself. The bacteria that live in these extreme sediments have evolved cellular mechanisms that seem to defy the basic principles of biology as understood from surface world organisms. Their cell walls incorporate pressure-resistant compounds that actually become stronger under extreme compression, while their metabolic processes operate through chemical pathways that exist only under the unique conditions created by crushing pressure combined with near-freezing temperatures and complete darkness. These bacterial communities create the foundation for one of Earth's most extreme ecosystems, supporting populations of microscopic organisms that represent some of the most pressure-adapted life forms ever discovered. Protozoa move through the pressure-modified sediments with specialized locomotory mechanisms that take advantage of the ultra-dense medium, while microscopic worms demonstrate body plans so radically altered by pressure adaptation that they challenge conventional taxonomic classifications. At 36,000 feet, the deepest point in Earth's oceans, you encounter the ultimate demonstration of life's ability to not just survive, but thrive under the most extreme conditions our planet can provide. Here, in the deepest part of the Mariana Trench, where pressure exceeds 1,100 times that at the surface, you find not a barren wasteland, but a thriving ecosystem that represents life's greatest triumph over what would seem to be impossible conditions. The water at this ultimate depth has a quality that seems almost supernatural in its density and support. It feels less like a liquid and more like a perfectly supportive medium that cradles every movement and enhances every sensation. The pressure here is so immense that it has fundamentally altered the physical and chemical properties of the water itself, creating an environment that exists nowhere else in the known universe. In this deepest place, you encounter microorganisms that push the very boundaries of what we consider possible for life. These bacteria and archaea have evolved under pressure so extreme that they represent a completely different approach to existence. Their cellular mechanisms so radically adapted to crushing conditions that they can only survive in environments that would instantly destroy all other known forms of life. The deepest dwelling organisms demonstrate adaptations that seem to transcend the normal rules of biology. Their cellular structures incorporate pressure into their very architecture, using the crushing force of the deep ocean as a fundamental organizing principle rather than a challenge to overcome. These organisms don't fight against pressure. They have become expressions of pressure itself, living embodiments of the creative potential that exists within even the most extreme conditions. As you rest in the deepest part of Earth's oceans, surrounded by pressure beyond anything experienced by any other complex organism in the history of our planet, you understand that you have witnessed something extraordinary. The Hadal Zone has revealed itself not as a place of destruction and impossibility, but as a realm of ultimate creativity where the most extreme conditions have given rise to the most remarkable forms of life. The organisms of the deepest trenches have shown you that there is no such thing as impossible conditions, only opportunities for life to express itself in new and more wonderful ways. Pressure, even at levels that seem beyond comprehension, becomes not a barrier, but a tool that life uses to create forms of beauty and efficiency that exist nowhere else in the universe. The gentle, omnipresent pressure that has supported you throughout your journey to the deepest places on Earth continues to create that wonderful sense of being perfectly supported and embraced by the ocean itself. Here, at the bottom of the world, you have discovered not an ending, but a beginning, a place where the most extreme conditions have given rise to the most extraordinary life, demonstrating that in the deepest places of our planet, pressure creates not destruction but transcendence, not limitation but infinite possibility. The trenches of wonder have revealed their secrets, that life's creativity knows no bounds, that the most crushing conditions can become the most liberating, and that in the deepest, most pressure-rich places on Earth, existence itself becomes an art form practiced by organisms so perfectly adapted to their extreme world that they represent evolution's greatest masterpieces, living proof that there is no place so deep, no pressure so great, that life cannot find a way to not just survive but flourish in beauty and wonder. As you rest in the profound depths of the ocean's deepest places, surrounded by pressure that has shaped life into forms of impossible beauty and efficiency, You begin to understand the fundamental principles that allow organisms to not just survive, but thrive under conditions that would seem to make life impossible. The crushing depths around you have become a laboratory where evolution has conducted its most ambitious experiments, creating biological solutions that demonstrate the infinite creativity of life when faced with the ultimate challenges. The secret to life under extreme pressure lies not in resistance, but in collaboration. Every organism you have encountered on your journey through the crushing depths has revealed a fundamental truth. Pressure is not an enemy to be fought, but a partner to be embraced. The creatures of the deep ocean have discovered ways to incorporate pressure into their very being, using the crushing force of the deep ocean as a tool that enhances rather than constrains their biological potential. At the cellular level, pressure adaptation reveals itself as one of nature's most elegant engineering solutions. The bacteria thriving in the deepest trenches have modified their cell walls with specialized compounds that actually become stronger under extreme pressure. These pressure-resistant molecules work like microscopic springs, using the crushing force of the deep ocean to maintain cellular integrity while allowing for the complex chemical processes that sustain life. The cell membranes of these deep-sea organisms are composed of unique lipids that remain fluid and functional under pressures that would turn normal cellular membranes into rigid, non-functional structures. The proteins that enable life under extreme pressure represent some of evolution's most sophisticated molecular engineering. These specialized molecules have been modified through millions of years of evolution to not just maintain their shape and function under crushing pressure, but to actually work better under extreme conditions than their shallow water counterparts. The protein structures incorporate additional molecular bonds and specialized folding patterns that use pressure as a stabilizing force, creating biological machinery that operates with enhanced efficiency in the crushing depths. Deep-sea organisms have solved the challenge of pressure through innovations in their circulatory systems that seem almost magical in their effectiveness. Many deep-sea fish have evolved blood that contains specialized compounds to prevent gas embolism, the formation of dangerous bubbles that could form if pressure were suddenly reduced. Their cardiovascular systems operate under principles that take advantage of pressure rather than fighting against it, using the dense medium of the deep ocean to enhance circulation efficiency and oxygen delivery to tissues. The nervous systems of pressure-adapted organisms reveal how extreme conditions can actually enhance rather than impair biological function. The neural tissues of deep-sea creatures are modified to work optimally under crushing pressure, their nerve impulses traveling more efficiently through the dense, pressure-rich medium that surrounds them. Many deep-sea organisms actually think and react faster than their shallow water relatives, their nervous systems enhanced by the stable, supportive environment created by extreme pressure. Reproduction under extreme pressure has led to some of evolution's most creative solutions to the challenges of finding mates and raising offspring in the vast, sparsely populated depths. Many deep-sea anglerfish have evolved the remarkable strategy of sexual parasitism, where the much smaller male permanently fuses with the female's body. This biological innovation allows a single successful mating encounter to provide a lifetime of reproductive potential, perfectly adapted to an environment where encounters between individuals are rare and precious. The reproductive cells themselves, eggs and sperm, show remarkable adaptations to pressure that demonstrate life's ingenuity in protecting its most precious cargo. Deep-sea fish eggs are often surrounded by specialized protective layers that use pressure as a stabilizing force, maintaining the delicate internal environment needed for embryonic development while withstanding the crushing conditions of the deep ocean. The development of these embryos follows modified patterns that take advantage of the stable pressure environment, resulting in offspring that are perfectly adapted to their extreme world from the moment of hatching. Feeding strategies under extreme pressure reveal how crushing conditions can create opportunities rather than limitations. Many deep-sea organisms have evolved feeding mechanisms that actually work more efficiently under high pressure than they would in shallow water. Filter-feeding organisms use the density of pressure-rich water to create more effective feeding currents, while predators take advantage of enhanced sensory capabilities that pressure makes possible. The digestive systems of deep-sea organisms demonstrate remarkable adaptations that allow them to extract maximum nutrition from the limited food sources available in the crushing depths. These highly efficient digestive processes are enhanced by pressure, which helps break down complex organic molecules and extract nutrients that would be unavailable to shallow water organisms. Many deep-sea creatures can digest food items that would be inedible to surface-dwelling organisms. Their pressure-enhanced digestive systems capable of processing even the most resistant organic compounds. Pressure adaptation has led to innovations in locomotion that create forms of movement impossible in any other environment. The dense, supportive medium of the deep ocean allows for forms of propulsion that take advantage of pressure rather than working against it. Deep-sea jellyfish can achieve remarkable efficiency by using pressure-enhanced muscle contractions, while soft-bodied organisms like octopuses can move through the water with precision and grace that would be impossible without the supportive pressure environment. The sensory capabilities of pressure-adapted organisms represent some of evolution's most sophisticated achievements in biological engineering. The lateral line systems of deep-sea fish can detect pressure waves and water movements with sensitivity that approaches the theoretical limits of biological detection. These enhanced sensory systems allow deep-sea organisms to navigate, hunt, and communicate in the absolute darkness of the crushing depths with precision that seems almost supernatural. Bioluminescence under extreme pressure reveals how crushing conditions can enhance rather than impair biological processes. The biochemical reactions that produce living light are actually stabilized and enhanced by extreme pressure, creating displays of bioluminescence that are more intense and longer-lasting than anything possible in shallow water. The pressure environment also allows bioluminescent signals to travel farther and with less distortion, creating communication networks that span vast distances in the deep ocean. The immune systems of deep-sea organisms have evolved to function optimally under extreme pressure, developing specialized mechanisms that protect against the unique challenges of the crushing depths while maintaining the complex chemical balances needed for life. These pressure-adapted immune systems often work more efficiently than their shallow water counterparts, providing enhanced protection against disease and environmental stress. In the deepest parts of the ocean, where pressure creates conditions unlike anywhere else on Earth, you discover that life has not just adapted to the extreme environment, but has used these conditions to build some of the most remarkable ecosystems on our planet. These underwater cities, centered around hydrothermal vents and cold seeps, demonstrate how pressure can become the foundation for complex communities that rival the rainforests in their diversity and productivity. As you approach a hydrothermal vent field at 8,000 feet beneath the surface, where pressure exceeds 240 times at the surface, you encounter a landscape that seems to belong to another world entirely. The seafloor here is dotted with towering, chimney-like structures that rise dozens of feet above the surrounding terrain. Each one a biological skyscraper built by organisms that have turned the extreme conditions of the deep ocean into opportunities for creating elaborate architectural wonders. The hydrothermal vents themselves are marvels of geological and biological engineering, where superheated water rich in minerals and chemicals erupts from the Earth's crust into the crushing depths of the ocean. The pressure at these depths plays a crucial role in maintaining the unique chemistry that makes these ecosystems possible. Under extreme pressure, water can remain liquid at temperatures that would create steam at the surface, allowing for the transport of dissolved minerals and chemical compounds that form the foundation of chemosynthetic life. Giant tube worms dominate the landscape around the vents, their crimson plumes waving gently in the mineral-rich currents like underwater flowers in an alien garden. These remarkable creatures have no mouth, no stomach, no digestive system in the conventional sense. Instead, they host specialized bacteria in their tissues that convert the chemicals spewing from the vents into energy and nutrients. The extreme pressure environment is essential to this process, helping to concentrate the chemical compounds and maintain the precise conditions needed for the symbiotic relationship between worm and bacteria. The tube worm's bodies demonstrate perfect adaptation to the pressure environment of the deep ocean. Their flexible, pressure-resistant tissues can withstand not only the crushing depths, but also the thermal stress created by living next to superheated water vents. The worms use pressure as a structural support system, their bodies essentially scaffolded by the dense, supportive medium that surrounds them. Individual worms can grow to over 8 feet in length. Their massive size made possible by the pressure environment that provides consistent support for their elongated bodies. Around the base of the tube worm colonies, the seafloor teems with specialized crustaceans that have evolved to thrive in the unique conditions created by the combination of extreme pressure and chemical-rich water. Yeti crabs, covered in hair-like filaments that may harbor their own symbiotic bacteria, move slowly through the vent fields with deliberate grace. These creatures demonstrate remarkable adaptations to both pressure and the toxic chemical environment around the vents. Their specialized filters and detoxification systems working more efficiently under extreme pressure than would be possible in shallow water. The pressure environment enhances the effectiveness of the chemical processes that drive vent ecosystems. The crushing depths help dissolve and concentrate the minerals and gases that emerge from the Earth's crust, creating chemical gradients that provide energy sources for the specialized bacteria that form the base of vent food webs. These bacteria are among the most pressure-adapted organisms on Earth, their cellular mechanisms requiring extreme pressure to function properly. Scale worms crawl across the surfaces of tube worms and rocky formations, their segmented bodies perfectly adapted to the pressure environment. These creatures demonstrate remarkable flexibility, their body segments able to compress and expand in response to pressure changes while maintaining the structural integrity needed for their scavenging lifestyle. The scale worms feed on organic matter and bacteria, their digestive systems enhanced by pressure to extract maximum nutrition from the limited food sources available in the vent environment. Deep-sea mussels cluster around areas where hydrothermal fluids mix with seawater, creating zones where temperature and chemical conditions are moderated by the vast thermal mass of the ocean. These mollusks have evolved specialized filtering systems that can extract nutrients from the chemical-rich water while protecting themselves from toxic compounds. The pressure environment enhances their feeding efficiency, allowing them to process larger volumes of water and extract more nutrients than their shallow water relatives. The mussel beds create microhabitats that support communities of smaller organisms adapted to the unique conditions of the vent environment. Polychaete worms burrow among the mussels, their bodies demonstrating remarkable adaptations to both pressure and the chemical challenges of vent life. These worms have specialized gills and circulatory systems that can process the chemical-rich water while maintaining the complex physiological balance needed for life under extreme pressure. Vent fish glide through the warm water columns above the hydrothermal features, their bodies showing clear adaptations to the unique conditions created by the combination of pressure and heat. These fish have evolved specialized proteins that remain stable under both extreme pressure and elevated temperatures, allowing them to exploit the productive vent environment while most other fish cannot tolerate the harsh conditions. The fish demonstrate hunting strategies that take advantage of the unique physics of the vent environment. They use the thermal currents and chemical gradients to locate prey, while their pressure-enhanced sensory systems allow them to detect the movements of small crustaceans and worms in the complex three-dimensional environment created by the vent structures. The dense, pressure-rich water provides excellent support for rapid movements, making these fish remarkably effective predators in their specialized habitat. Cold seeps represent another type of abyssal city, where hydrocarbons and other chemicals seep slowly from the seafloor, creating long-term oases of life in the deep ocean. Unlike the dramatic, short-lived hydrothermal vents, cold seeps can persist for decades or centuries, allowing for the development of complex, mature ecosystems that demonstrate how pressure enables long-term biological construction projects. The communities around cold seeps are dominated by different species than those found at hydrothermal vents, but they demonstrate the same fundamental principle. Pressure creates opportunities for chemosynthetic life that would be impossible in any other environment. Clam beds stretch across the seafloor around seep sites, the mollusks hosting their own populations of symbiotic bacteria that convert methane and hydrogen sulfide into energy and nutrients. These clams grow to enormous sizes in the pressure-rich environment of the deep ocean, some reaching lengths of over a foot. Their shells are reinforced with specialized proteins that become stronger under pressure, while their soft tissues demonstrate remarkable adaptations to both the crushing depths and the chemical challenges of their environment. The clams can live for centuries, their slow growth and exceptional longevity made possible by the stable conditions created by extreme pressure. Bacterial mats cover large areas around cold seeps, creating living carpets that support complex food webs. These bacterial communities represent some of the most pressure-adapted life forms on Earth. Their metabolic processes operating through chemical pathways that exist only under the unique conditions created by extreme pressure combined with chemical-rich environments. The bacterial mats support populations of grazing organisms that demonstrate remarkable specializations for life in the pressure-rich environment of the deep ocean. Small gastropods move slowly across the bacterial surfaces, their feeding mechanisms enhanced by pressure to extract maximum nutrition from their microscopic prey. These grazers play crucial roles in nutrient cycling within the seep communities, processing bacterial biomass and redistributing nutrients throughout the ecosystem. Deep-sea spider crabs move through the seep environments like underwater gardeners, tending to the bacterial mats and feeding on both living and dead organic matter. These creatures demonstrate remarkable adaptations to pressure, their jointed legs and specialized respiratory systems working more efficiently under extreme conditions than their shallow water relatives. The crabs use pressure-enhanced chemical senses to locate food sources and navigate through the complex, three-dimensional habitat created by seep communities. The architecture of these abyssal cities demonstrates how pressure enables biological construction on scales that would be impossible in shallow water. The stable, supportive environment created by extreme pressure allows for the construction of large, complex structures that can persist for decades or centuries. Tube worm colonies can grow into formations that resemble underwater skyscrapers, while bacterial mats can cover areas the size of football fields, creating some of the largest biological structures on Earth. These underwater cities represent more than just collections of organisms adapted to extreme conditions. They demonstrate how pressure can become a creative force that enables entirely new forms of ecological organization. The communities around vents and seeps show levels of interdependence and specialization that rival the most complex terrestrial ecosystems, yet they exist in conditions that would be instantly lethal to most surface-dwelling organisms. The energy flow through these pressure-enabled ecosystems follows patterns unlike anything found on the surface of the Earth. Instead of depending on sunlight and photosynthesis, these communities are powered by chemosynthesis, the conversion of chemical compounds into biological energy. This process is enhanced and enabled by the extreme pressure environment, which helps concentrate the chemical compounds and maintain the precise conditions needed for the complex biochemical reactions that sustain life in the abyss. As you observe these cities in the abyss, you understand that pressure has not just shaped individual organisms, but has enabled entirely new forms of biological organization and ecological complexity. The crushing depths of the ocean have become the foundation for some of Earth's most remarkable communities, demonstrating that even the most extreme conditions can become the basis for beauty, diversity, and life in its most creative and inspiring forms. In the vast expanses of the deep ocean, where pressure creates conditions that seem to defy the possibility of large, complex life, you encounter some of the most magnificent creatures on Earth, the gentle giants of the deep that have not only adapted to crushing pressure, but have used these extreme conditions to achieve sizes and forms of beauty that exist nowhere else on our planet. These remarkable beings demonstrate that pressure, far from limiting the scale of life, can actually enable organisms to grow larger and more graceful than their shallow water relatives. As you drift through the midnight waters at 6,000 feet, where pressure exceeds 180 times that at the surface, a massive form emerges from the blue-black depths ahead of you. A deep-sea gigantism has created a siphonophore colony that stretches through the water like a living galaxy, its bioluminescent sections pulsing with gentle rhythms that seem to slow time itself. This colonial organism, reaching lengths that can exceed 150 feet, demonstrates how pressure enables biological architecture on scales that would be impossible in the chaos of surface waters. The siphonophore's immense size is made possible by the stable, supportive environment created by extreme pressure. Each individual zooid within the colony is perfectly adapted to the crushing depths, their tissues reinforced by pressure-resistant proteins, while their connections to neighboring zooids are strengthened by the dense, supportive medium that surrounds them. The colony moves through the water with coordinated grace, each section responding to environmental cues and internal signals with precision that seems almost telepathic. The giant siphonophore's hunting strategy reveals how pressure enhances predation on unprecedented scales. The colony extends fishing lines equipped with bioluminescent lures throughout a volume of water that can encompass several city blocks, creating a three-dimensional trap that takes advantage of the water's density to maintain its structure and effectiveness. When prey organisms are captured, the colony can coordinate the retrieval of food across its entire length, sharing nutrients among hundreds of individual zooids in a display of biological cooperation that rivals the most sophisticated human organizations. A deep-sea jellyfish approaches, its bell measuring over 6 feet in diameter, moving through the pressure-rich water with pulses so slow and powerful they seem to massage the ocean itself. This giant medusa represents another example of how pressure enables size increases that transform familiar organisms into creatures of almost mythical proportions. The jellyfish's massive bell is supported not by rigid structures, but by the pressure environment itself, which provides consistent external support that allows for the development of tissue architectures impossible in shallow water. The giant jellyfish's bioluminescence creates displays that illuminate vast volumes of the deep ocean, its photophores arranged in patterns that pulse with wave-like motions across its enormous bell. The pressure environment enhances these light displays, stabilizing the biochemical reactions and allowing the signals to travel farther through the dense medium. When a jellyfish feeds, it can engulf prey organisms in volumes of water that would dwarf most surface predators, its massive bell creating currents and pressure waves that concentrate food particles across enormous distances. As you continue through the deep ocean, you encounter a sperm whale diving to depths that would crush most air-breathing animals. Yet this magnificent giant moves through the pressure-rich water with grace that seems effortless. The whale's adaptation to extreme pressure represents one of evolution's most remarkable achievements in mammalian engineering, allowing a warm-blooded, air-breathing creature to hunt in the crushing depths where giant squid make their homes. The sperm whale's body demonstrates sophisticated pressure adaptation that allows it to dive to depths exceeding 7,000 feet, where pressure reaches over 200 times surface levels. The whale's lungs collapse completely during deep dives, eliminating gas-filled spaces that could cause problems under pressure, while its blood and tissues contain enhanced oxygen-carrying capacity that allows for hunting expeditions lasting over an hour in the crushing depths. The whale's massive head contains specialized organs filled with spermaceti oil that may help with buoyancy control and pressure adaptation during extreme dives. When the whale hunts giant squid in the deep ocean, the encounter represents a meeting between two of evolution's most magnificent achievements in pressure adaptation. The giant squid, with bodies that can exceed 40 feet in length, have evolved to thrive in the pressure-rich environment of the deep ocean, their soft tissues perfectly adapted to the crushing depths while maintaining the strength and agility needed to avoid predation by diving whales. The giant squid's hunting strategy demonstrates how pressure enables predation on scales that dwarf anything possible in shallow water. Using arms that can extend over 30 feet and equipped with hooks larger than dinner plates, the squid can capture prey across volumes of water that encompass thousands of cubic feet. The pressure environment enhances the squid's jet propulsion system, allowing for rapid acceleration and maneuvering that can propel its massive body through the water with startling speed and precision. The squid's chromatophores work with enhanced precision under pressure, creating color displays across its enormous body surface that can communicate complex information or create camouflage patterns that make a 40-foot animal virtually invisible in the deep ocean. The pressure environment stabilizes these color-changing mechanisms, allowing for displays of complexity and subtlety that would be impossible for smaller, shallow water relatives. Deep-sea sharks represent another group of gentle giants that have used pressure to enable size increases and behavioral modifications that create some of the ocean's most impressive predators. The Greenland shark, capable of reaching lengths over 20 feet and living for centuries, moves through the deep Arctic waters with movements so slow and deliberate they seem meditative, yet represents one of the most successful predators in the polar deep ocean. The Greenland shark's adaptation to both extreme pressure and near-freezing temperatures demonstrates how multiple environmental extremes can combine to create opportunities for unique life forms. The shark's tissues contain antifreeze compounds that prevent ice crystal formation, while its metabolism operates at rates so slow that individual sharks may live for over 400 years. The pressure environment supports this extremely slow lifestyle, providing stable conditions that allow for biological processes operating on timescales that dwarf human experience. The six-gill shark, another giant of the deep ocean, demonstrates how pressure adaptation can preserve ancient body plans that have remained virtually unchanged for hundreds of millions of years. These living fossils can reach lengths of over 20 feet while diving to depths exceeding 8,000 feet. Their primitive but perfectly effective anatomy, enhanced by pressure adaptations that allow them to exploit deep water environments unavailable to more modern shark species. The six-gill shark's hunting behavior in the deep ocean reveals how pressure can enhance rather than constrain predatory effectiveness. Moving slowly through the pressure-rich water, the shark uses enhanced sensory systems to detect prey across vast distances, its primitive but highly effective lateral line system operating with remarkable sensitivity in the dense medium of the deep ocean. When it strikes, the shark's ancient but perfectly adapted jaws can process prey with efficiency that has remained unchanged since the age of dinosaurs. Giant deep-sea isopods, crustaceans that can reach lengths of over a foot, demonstrate how pressure enables arthropods to achieve sizes that would be impossible for their terrestrial relatives. These gentle giants move slowly across the deep seafloor, processing organic matter and serving as important decomposers in the pressure-rich environment of the abyss. Their exoskeletons are reinforced with pressure-resistant compounds that actually become stronger under extreme conditions, allowing them to maintain structural integrity while growing to sizes that dwarf their shallow water cousins. As your remarkable journey through the pressure-rich depths of the ocean draws to a gentle close, you begin a slow, peaceful ascent that allows you to reflect on the profound transformations you've witnessed in the deepest places on Earth. The crushing depths that once seemed impossible for life have revealed themselves as realms of incredible beauty, innovation, and biological artistry, where pressure becomes not a barrier, but a creative force that enables life to express itself in ways that exist nowhere else in the universe. Rising slowly from the deepest trenches, you carry with you new understanding of how the most extreme conditions can become the foundation for the most extraordinary life. The organisms of the hadal zone, living under pressure that exceeds 1,100 times surface levels, have shown you that there are no limits to life's creativity when faced with conditions that seem to make existence impossible. These deepest dwellers have transformed crushing pressure into a tool for creating forms of beauty and efficiency that represent evolution's greatest masterpieces. As you ascend through the abyssopelagic zone, passing through waters where pressure slowly decreases from over 600 times surface levels, you reflect on the remarkable communities you've encountered in the crushing depths. The hydrothermal vent cities and cold seep ecosystems have demonstrated how pressure enables complex biological architecture and ecological relationships that rival the most sophisticated surface ecosystems. These underwater metropolises prove that even in the most extreme environments, life finds ways to create beauty, diversity, and intricate social organization. The gentle giants of the deep ocean, those magnificent creatures whose size and grace are made possible by the supportive pressure environment, have shown you how extreme conditions can enable rather than constrain biological achievement. From giant siphonophores stretching longer than blue whales to massive deep-sea jellyfish, whose bioluminescent displays illuminate vast volumes of the midnight ocean. These creatures represent life's ability to use pressure as a tool for achieving scales of existence that seem almost magical. Rising through the bathypelagic zone, where pressure decreases from over 400 times surface levels, you remember the bioluminescent galaxies of the midnight waters, where darkness has become not a limitation, but an opportunity for creating some of nature's most beautiful light displays. The pressure-enhanced bioluminescence you've witnessed represents more than just biological illumination. It demonstrates how extreme conditions can refine and perfect biological processes until they become forms of living art. As you ascend through the mesopelagic twilight zone, where pressure drops from over 90 times surface levels, you recall the remarkable vertical migrations you've observed, the largest animal movements on Earth, made possible by organisms whose pressure adaptations allow them to travel hundreds of feet through the water column daily. These migrations represent life's ability to use pressure gradients as highways, connecting different oceanic realms and enabling energy transfer on scales that influence global ocean productivity. The remarkable fish of the twilight zone, with their sophisticated pressure compensation organs and enhanced sensory systems, have shown you how moderate pressure increases can serve as stepping stones toward more extreme adaptations. These creatures demonstrate that pressure adaptation is not an all-or-nothing proposition, but a gradual process that enables life to colonize increasingly challenging environments while maintaining the complexity and beauty that characterize successful organisms. Ascending through the upper ocean, where pressure decreases to levels only a few times greater than surface pressure, you appreciate anew the elegant adaptations that allow marine life to move freely between different pressure environments. The simple swim bladders of shallow water fish, the pressure-sensitive lateral line systems, and the flexible body plans of marine organisms all represent foundational adaptations that make possible the more extreme modifications you've witnessed in the deepest waters. As you approach the ocean surface, where pressure returns to the single atmosphere that characterizes your normal experience, you realize that your journey has transformed your understanding not just of pressure, but of life itself. You've discovered that what seems limiting can become liberating, that what appears hostile can become nurturing, and that what looks impossible can become not just possible, but beautiful beyond imagination. The surface waters that welcome your return seem different now, not diminished by their lower pressure, but appreciated as part of a continuum that extends from the lightest touch of atmosphere to the crushing embrace of the deepest trenches. Every drop of seawater carries within it the memory of depths where pressure has shaped life into forms of incredible beauty and adaptation, connecting the surface world to realms of pressure-enabled wonder that stretch toward the very center of the earth. As you float peacefully on the gentle surface waves, feeling the familiar pressure of Earth's atmosphere surrounding your body, you understand that pressure is not just a property of the deep ocean, but a fundamental force that shapes every aspect of existence on our planet. From the atmosphere pressure that makes weather possible to the internal pressure that drives circulation in living organisms, pressure reveals itself as one of the fundamental organizing principles of life itself. The ocean's surface, dancing with patterns of light and shadow, carries within its movements the influence of pressure systems that span the globe. The gentle waves that support your floating body are driven by pressure differences in the atmosphere, while the currents beneath you are shaped by pressure gradients that connect every part of the ocean in an endless dance of movement and exchange. Resting here on the surface, you feel profoundly connected to the entire water column that extends beneath you to the deepest trenches. Every breath you take connects you to the pressure-adapted organisms below. Every movement through the water links you to the vast community of life that has learned to use pressure as a creative force rather than a limiting constraint. The twilight sky above reflects perfectly in the calm surface around you, creating a moment of perfect symmetry between the atmospheric ocean above and the liquid ocean below. In this peaceful moment, you understand that pressure creates not separation but connection, not barriers but bridges that link every part of our planet's interconnected systems of life and movement. As the first stars appear in the darkening sky above, their light beginning the long journey that will carry it through the atmosphere and deep into the ocean's pressure-rich depths, you feel ready to rest. Your journey through the crushing depths has revealed that pressure, far from being a force of destruction, is one of nature's most powerful tools for creation, adaptation, and the endless elaboration of beauty and complexity that characterizes life on Earth. The gentle pressure of the atmosphere around you, so familiar and unnoticed in daily life, now feels like a blessing rather than a burden. You understand that you live your entire life supported and embraced by pressure, just as the creatures of the deep ocean are supported by the crushing depths that enable their remarkable adaptations and beautiful existence. As sleep begins to settle over you like the gentle descent through peaceful waters, you carry with you the memory of life thriving under impossible conditions, of beauty emerging from the most extreme challenges, and of pressure revealing itself not as a force to be feared, but as one of the fundamental creative principles that makes possible the incredible diversity and wonder of life on our remarkable planet. The ocean's gentle rhythm rocks you toward dreams where pressure becomes poetry, where crushing depths transform into embracing support, and where the deepest places on Earth reveal themselves as realms of infinite possibility and transcendent beauty, demonstrating that there is no condition so extreme that life cannot find a way to not just survive, but flourish in ways that inspire wonder, gratitude, and peaceful rest.